a very common pattern for our kind of data, or in general for like AI data, is that like hit and run pattern. So we're processing billions and hopefully soon trillions of data points. What are the challenges that you see that are coming with that on our end?
Typically, we'll have like two different databases, and you need to sync from application side into the data warehouse. And with so many data, it's actually very challenging. We were using some tools, but with the amount of data we have, it's kind of like a little bit approaching a limit. And so we might also need to build our own data pipeline.
Right. And these CDC tools obviously also have limits. For example, like one of like the CDC tools that we evaluated and we looked at has like somewhere between 2 MB per second to 80 MB per second throughput. So I think that is one of the challenges that we're facing, that like at some point, like the bigger we're growing, if we get to like trillions of data points, whatnot, we inevitably have to shard in whichever way, because like you have to then separate and divide the points of where we transmit data, where we use the CDCs. So we have to split them apart, and that brings additional complexity. And one of the solutions that we're thinking about right now and that we're actually discussing these days, since we're in a state of where we have actual hot data, right? Chat data is hot when you create a new chat, and you forget about your new chat after like a day or two, most of the time. Why not have an ephemeral system that you could replace at any point of time, so that you can actually throw away? So say like 7 days of time to live, and then like move all of the data from that. So replicate all of the data to a cold system. That flexibility also allows us to like have these hot data systems sharded, and then like separate the throughput to different CDC replications, which also allows us to flexibly grow. A very common pattern for our kind of data, or in general for like AI data, is that like hit and run pattern, right? So nowadays there is some change that we're seeing. Obviously, there is something like we're creating projects and we're having more context in AI models available. So you could actually say that people are doing more and more of this, like just keep the memory, just keep the context, and like I'm revisiting this every day, for example, for company knowledge, whatever, whatnot. But currently what we're seeing in our data is just like the most of the time the hit and run, and we might end up doing something like the projects as well.
So let's say that I'm in a situation where we don't want to shard, or we just don't have the ability to shard. What are some other options that are available to me as I scale?
I do truly think that eventually sharding is inevitable. But the question is, do you have to do the sharding?
Okay.
I think that's more of a question. Because, for example, there are solutions like, for example, like there's that new thing that's called DSQL, AWS DSQL, which is basically a serverless. They changed Postgres to become serverless, and it kind of infinitely scales, but it's still sharding. It's just like abstracted sharding. And the same goes with, for example, Aurora Limitless, or let it be, for example, like Azure Cosmos DB for Postgres, which is just Citus, right? Or YugabyteDB. So those are definitely options if you don't want to like care about doing it yourself. Then you have these options which have horizontal sharding built in. So you're paying for that peace of mind of not having to do the sharding. And that is definitely one solution that you can go for. Same for Spanner, for example, Google Spanner. And those solutions have that built in, but eventually, just from a technical perspective, it's still sharding. As I said, like you will end up doing sharding at some point, but the question is, do you want to manage that on your own? Do you actually want to do like Notion did, like managing all of the Postgres clusters? Or do you want to rely on a managed service for that?